Welcome to Let's Get to the Marks. This is question 6 of the 2023 AS Paper 2 for AQA Chemistry. There's questions about intermolecular forces in some organic compounds. Table 4 gives us some information about three organic compounds. We got their boiling points and the polarity of the molecules. State why the CCl bonds in dichloromethane and tetrachloromethane are polar. Why don't you pause the video, have a go at the question, and then watch the walkthrough. So for 6.1, it says state why the carbon-chlorine bonds in dichloromethane and tetrachloromethane are polar. The reason is there's a difference in the electronegativity, the ability to withdraw electrons or pull electrons towards yourself. There's a difference in the electronegativity of the two atoms. And in fact, chlorine is a lot more electronegative than carbon. So it becomes delta negative and the carbon becomes delta positive. And that's why we describe the bond as polar. Now for 6.2, the question says, suggest why tetrachloromethane molecules are non-polar. So that's the middle one in the table there, tetrachloromethane. What you'll find with tetrachloromethane is although it contains four polar bonds with the delta negative chlorine and the delta positive carbon, the electronegative chlorines and the carbons are symmetrical and evenly spread out. And so the charges cancel each other out. So there's no overall polarity on that molecule. It is a non-polar molecule. And that is down to the charges cancelling out. Now we're going to move on to 6.3. So once again, pause the video and have a go. Explain why tetrachloromethane has a higher boiling point than dichloromethane. So tetrachloromethane, again, it's got these chlorine atoms that are delta negative and the carbon is delta positive. However, the charges cancel out. It's non-polar. But it's actually got a larger MR than dichloromethane, which means it has more electrons, a larger electron cloud than dichloromethane. And that's because dichloromethane contains two hydrogens instead of two chlorines, which it would if it was tetrachloromethane. So the tetrachloromethane being a bigger molecule with more electrons or having a larger MR means that it has stronger van der Waals forces. Now, the forces between the molecules are van der Waals forces or temporary dipole-dipole forces, and these are stronger than the permanent dipole forces that are found in the dichloromethane, purely due to the size of the molecule. Now, the dipole-dipole forces alone, if you were to compare one dipole-dipole force to a van der Waals force, a dipole-dipole force is a slightly stronger intermolecular force. But due to the fact that the tetrachloromethane is so much bigger than the dichloromethane, the van der Waals forces in tetrachloromethane are stronger than the dipole-dipole forces in dichloromethane. And that's due to the amount of the van der Waals forces. Okay, cool. So now we're going to move on to 6.4. This is the last part of the question. Let's just get this into focus. 6.4, propan 1-ol has a higher boiling point than the other two compounds because of hydrogen bonding. Describe hydrogen bonding in propan 1-ol. So you can have hydrogen bonding if you contain a hydrogen atom which is bonded to either oxygen, fluorine, or nitrogen. Hydrogen to fluorine, hydrogen bonding is the strongest, then hydrogen to oxygen, then hydrogen to nitrogen like you find in amino acids or proteins. Okay, well, propan 1-ol contains the OH bond. And you just need to describe what is a hydrogen bond here. So I'm using the molecule, the rest of the chain as an R, and then we've got the OH. We've got the delta positive hydrogen atom. The hydrogen bond forms between the delta positive hydrogen on one alcohol molecule and the lone pair on the oxygen of an adjacent, neighboring, or another alcohol molecule. So hydrogen bonding forms between two alcohol molecules, or many more than that, alcohol molecules, but in between two molecules, and it's between the delta positive hydrogen on one and the lone pair of electrons on the oxygen on another alcohol. Cool. And that's what gives propan 1-ol the highest boiling point out of these ones. Sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks. See you in the next video.
You're still here? It's over.